Leverage game-changing fidelity. Bring incredibly immersive and realistic interactive experiences to life with groundbreaking new features like Nanite and Lumen that provide a generational leap in visual fidelity. And enable worlds to be fully dynamic. Build bigger worlds. Think big, really big. Unreal Engine 5.0 provides the tools and assets you need to create truly expansive worlds for your players to explore, using content that scales. Animate and model in context. New artist-friendly animation authoring, retargeting, and runtime tools, together with a significantly expanded modeling toolset, reduce iteration and eliminate round-tripping. Speeding up the creative process. Get up to speed faster. With a modern, flexible UI that offers an enhanced user experience and increased efficiency. Updated industry-specific templates that act as more useful starting points. And migration guides that provide a smooth transition from previous versions for existing users. Unreal Engine 5.0 is easier to adopt and learn than ever before. This release includes improvements submitted by the incredible community on GitHub. Of these contributors: Alex Thiv, Alwyn Tom, Adina Bedi, Afnet, Kongu 1977, Death3, Dianicolou, Dorganman, Error 454, Erabel 55, Fubert. Fields Jackson G, Microsoft, GG Sharkmob, Hatch Q, Inicide, Imaginary Blend, Ignacio FDM, Intel, Jorge NPT, Casp1, Kershish, Liuhao 0620, Matthew JNV, Nvidia, Mastercoms, Much Charles, Project Geist. Random Inequalities, Stanley 1108, Scorpio 20T, Tuxa, Oculus, Theo Hay, Velvet 22. Rendering Lumen Global Illumination and Reflections. Lumen is a fully dynamic global illumination and reflections solution that immediately reacts to scene and light changes, offering artists and designers the ability to create more dynamic scenes with greater realism. Changing the angle of the sun, turning on a flashlight, opening an exterior door, or even blowing up a wall will cause a change to indirect lighting and reflections. The system renders diffuse into reflection with infinite bounces and indirect specular reflections, highlighting even the most minute details within expansive, elaborate environments. Artists and designers are no longer tied to static scenes with pre-computed lighting baked into textures, a huge time saving when you can see the results of changes right in the editor without needing to rebuild lighting, or to set up light map UVs for individual static meshes. Lumen implements efficient software ray tracing, allowing for global illumination and reflections to run on a wide range of video cards, while supporting hardware ray tracing for high-end visuals. Since the launch of Unreal Engine 5 Early Access, Lumen has seen the following improvements. Full hardware ray tracing pipeline for Lumen GI and reflections shipped on next general consoles. In the Matrix Awakens, support for large view ranges with far-field hardware ray tracing feedback-driven surface cache, giving higher quality in reflections. Lumen visualization view modes for troubleshooting content. Improved final gather quality, especially visible on foliage. Improved reflections denoiser, especially for glossy reflections and behind moving objects. Translucency final gather, which improves global illumination quality on translucency and volumetric fog landscape. Support radiosity final gather, which improves the quality of multi-bounce global illumination and GI seen in reflections lumen settings exposed to the user interface for quality, performance trade-off subsurface, two-sided foliage. Shading models supported for more. See the Lumen Global Illumination and Reflections documentation. Nanite Virtualized Geometry. Nanite's virtualized micropolygon geometry system enables developers to create games with massive amounts of geometric detail. You can directly import film-quality source art composed of millions of polygons, anything from ZBrush sculpts to photogrammetry scans, and place them millions of times, all while maintaining a real-time frame rate, and without any noticeable loss of fidelity. Nanite intelligently streams and processes only the detail you can perceive, largely removing triangle count and draw call constraints. It eliminates time-consuming work, such as baking details to normal maps and manually authoring levels of detail, freeing you to concentrate on creativity. Image_3.png. Since the launch of Unreal Engine 5 Early Access, Nanite has seen the following improvements. Optimization controls to reduce the size of Nanite meshes on disk. This allows for optimizati on of meshes during development by removing the least significant data first so that it's more akin to lossy compression. For example, in the technical demo, Lumen in the Land of Nanite, the chest piece of one of the statues was able to lose 88% of its triangles and disk size, without any noticeable differences. Compression improvements resulting in approximately 20% smaller disk footprint for Nanite meshes at the same quality. For projects converting from UE4 to UE5, the Nanite auditing tool can assist with moving a lot of existing content over to use Nanite and to diagnose Nanite content that becomes broken during development, such as unsupported features being enabled. Image_4.png. The tool audits static meshes in two categories. Errors displays issues with Nanite-enabled meshes, such as material incompatibilities with alpha test, world position offset, pixel depth, and so on. Optimize displays opportunities to enable Nanite on non-Nanite meshes, assuming no incompatibilities are detected. Access this tool from the main menu by selecting Tools, Nanite Tools. Nanite meshes now support general view modes like wireframe and shader complexity optimization. The shader complexity view mode shows a heat map of shader instruction counts per pixel, encompassing all rendered objects. Nanite's existing material complexity view mode shows a heat map of the number of unique materials on Nanite geometry only per 8x8 tile, which is a useful metric for determining material coherency in the Nanite pass. Improvements for Nanite meshes to support light maps without artifacts on UV seams. Nanite now requires DX12 on Windows. DX11 is no longer supported. For more, see the Nanite Virtualized Geometry documentation. Virtual Shadow Maps. Beta. Virtual shadow maps provide the next generation of dynamic shadowing for real-time, taking advantage of Unreal Engine 5's Nanite and world partition features. They offer consistent high-quality shadows, as needed for film-quality assets and large open worlds. Traditional dynamic shadowing techniques have often been limited to small and medium-sized worlds, sacrifice quality for performance. By contrast, virtual shadow maps offer a single unified shadowing method that automatically applies quality where it is needed most. Shadows can now have consistent quality for small and large objects over greater distances, with realistic soft penumbra and contact hardening. ChatGPT Part 2. Virtual shadow maps leverage the power of Nanite to handle high-resolution geometry without sacrificing performance. They provide accurate, detailed shadows for even the most complex scenes. Here are some key features and improvements of virtual shadow maps since the launch of Unreal Engine 5 Early Access. Enhanced quality. Virtual shadow maps offer improved shadow quality with better filtering, reducing shadow aliasing and producing smoother, more realistic shadows. Soft shadows. Realistic soft penumbra and contact hardening are supported, creating more natural and believable lighting effects. Efficient memory usage. Virtual shadow maps optimize memory usage by automatically allocating more memory to areas that require higher shadow quality and reducing memory consumption in less critical areas. Performance optimization. Unreal Engine 5 optimizes the rendering pipeline to ensure efficient performance when using virtual shadow maps, allowing for real-time shadowing in demanding scenes. Integration with world partition. Virtual shadow maps seamlessly integrate with Unreal Engine 5's world partition feature, allowing for efficient streaming and dynamic loading of shadow data in large open worlds. It's important to note that virtual shadow maps are still in the beta phase, which means there may be some limitations and ongoing improvements being made. However, they provide a significant advancement in dynamic shadowing technology within Unreal Engine 5. For more detailed information on virtual shadow maps, including usage and implementation guidelines, you can refer to the Unreal Engine documentation. Please let me know if you have any further questions or if there's anything else I can assist you with. User It goes on. Since Unreal Engine 5 Early Access, the Virtual Shadow Maps system has received the following improvements. New visualization modes for the level editor image_7.png, improved scenes with foliage by integrating virtual shadow maps with distance field shadows for far field rendering, added support for more geometry types, added support for simple, subsurface and foliage materials. Subsurface profile and transmission are not yet supported. Improved robustness, performance, and quality for caching, support for large world coordinates, experimental, support for separate static caching. Virtual shadow maps now require DX12 on Windows. DX11 is no longer supported. For more, see the Virtual Shadow Maps documentation. Temporal Super Resolution Nanite Micropole. Wygon geometry and the fidelity demands of next-generation games have increased the amount of detail that is possible to display on screens like never before. To meet those demands, the temporal super resolution algorithm has been developed from scratch as a replacement for Unreal Engine 4's temporal anti-aliasing (TAA) for higher-end platforms. Temporal super resolution provides native high-quality upsampling built into Unreal Engine and supports a broad array of hardware. Temporal super resolution is the default anti-aliasing method and is enabled for all projects. Temporal super resolution has the following properties. Output approaches the quality of native 4K renders with input resolutions as low as 1080p, allowing for both higher frame rates and better rendering fidelity. Less ghosting against high-frequency backgrounds than was visible with UE4's temporal anti-aliasing. Reduced flickering on geometry with high complexity. Supports dynamic resolution scaling on consoles. Runs on any hardware that supports D3D11, D3D12, Vulkan, Metal, PlayStation 5, and Xbox Series S, X. Supports DirectX 12 Shader Model 6. Shaders have been specifically optimized for PlayStation 5 and Xbox Series S, X GPU architectures. In the comparison below, we show the quality and performance differences between captured frames rendered at native 4K and 4K rendered at 1080p resolution upscaled. Using temporal super resolution, it is possible to achieve image quality near native 4K resolutions and reduce GPU frame time by nearly 50%. In each of the comparison images, the 4K images are limited to the width of this page. To see their full, uncompressed resolution, right-click on either image and choose Open in New tab or Save Image as. Path Tracer Improvements, Beta. The Path Tracer continues to see improvements in Unreal Engine 5.0 with its physically correct and compromise-free results. It can be used for ground truth comparisons, standalone frame renders, and with sequences movie render queue to render frames for high-quality cinematics. This release has improvements with material support, eye-hair, experimental, alpha channel native ray traced depth of field solid glass now supports color absorption, using Beer's law, which allows for realistic coloring of refractive glass image _10.png image _11.png image _12.png image _13.png, a path tracing quality switch expression that allows artists to develop the behavior of their materials for the path tracer without compromising the look and performance of the raster path for real-time improved sampling and performance. For additional information, see the path tracer documentation. Local exposure post-processing. Local exposure is a new technique that automatically applies local adjustments to exposure, within artist-controlled parameters, to preserve both highlight and shadow detail on top of the existing global exposure system. This is especially useful for projects with challenging high dynamic range scenes using dynamic lighting, in which applying a single global exposure adjustment is not enough to avoid blown-out highlights and completely dark shadows. For example, in games with dynamic time of day systems, players can easily encounter scenes with both under- and overexposed areas in the final image, such as indoor scenes with very bright outdoors visible through a door or window, which can be problematic for gameplay. Using local exposure helps achieve a more consistent final image when carefully crafted lighting per scene is not feasible. Local exposure properties are found in the post-process volume settings under the lens, local exposure category. Image _16.png to see how local exposure is being applied to the scene. Use the visualization found in the level viewports show, visualization menu. Image _17.png to learn more about local exposure, see auto exposure. Post-motion blur translucency. Certain effects, such as in-world UI elements, suffer from quality degradation and artifacts when rendered in the current translucency passes due to post-processing. Effects such as motion blur and temporal anti-aliasing. Unreal Engine 5.0 introduces a new post-motion blur translucency pass that gives artists a way to create translucent materials that are not affected by motion blur or temporal anti-aliasing. You can assign translucent materials to the post-motion blur pass in the Details panel. Properties of the material. Under the Translucency, Advanced section, select After Motion Blur from the Translucency Pass drop-down menu. This means that objects rendered after motion blur cannot be occluded by other objects in the scene, even if they are closer to the camera. Material Editor Collapsible Nodes. Collapse nodes is a new feature in the Material Editor that gives you the ability to collapse a selection of material expressions or functions into a single node in The material graph. This allows you to simplify the appearance of complex material networks, making them easier to read and interact with. At any time, you can revert collapsed nodes to their original configuration by right-clicking a collapsed node and choosing Expand Node from the context menu. Image_20.gif DirectX 12 Microsoft's DirectX 12, DX12, is now the recommended RHI for Windows PCs using Unreal Engine 5 features. As DX12 support matures in the engine, memory management, feature completeness, and stability are top priorities. Newly created projects in Unreal Engine 5 will use DX12 by default. Vulkan. The Vulkan RHI has received numerous stability and feature updates in Unreal Engine 5 that improve usage for both desktop and mobile. This includes support of Unreal Engine 5 features like Nanite and Lumen, with software ray tracing only, on Linux. For requirements, see the hardware and software specifications documentation. World Partition for large, open environments. World Partition is an automatic data management and streaming system used both in the editor and at runtime, which completely removes the need to manually divide the world into countless sublevels to manage streaming and reduce data contention. Using World Partition, the world exists as a single persistent level. In Editor, the world is split using a 2D grid and data is partially loaded based on your area of interest using the World Partition Editor window. This makes it possible to handle massive worlds that would otherwise not fit in memory or take a long time to load. When cooking or launching Pi, the world is divided into grid cells optimized for runtime streaming, which become individual streaming levels. Image_21.jpg World Partition has continued to receive improvements since the Unreal Engine 5.0 early access release. New Open World and Open World Empty default map types streaming sources now support custom shapes, support for landscape brushes, new builder commandlets to automate batch processes and generate or modify data in World Partition levels. World Partition is enabled by default when using many of the new project templates designed for games, as well as the Open World and Open World Empty map types. For more information on using World Partition, please see our World Partition documentation. Data layers for World Partition. Data layers for World Partition is a system designed to conditionally load world data by activating and deactivating layers in the editor and at runtime. Data layers are an excellent way to organize your world in the editor. You can also use it to handle different scenarios in your game and create different variations of the same world. This is great for different setups for night and day, or changes to the world after completing quests. You can control data layers from the Data Layers tab in the editor or from Actors Details panels. Image_22.jpg for more. See the World Partition, Data Layers documentation. One file per actor. The new one file per actor system works with World Partition to make collaborative editing in a large world much easier. The level editor saves individual actors to their own files, rather than grouping them all into a single, monolithic level file. This means users only have to check out actors they really need from source control, rather than the entire level. This feature is now enabled by default when using World Partition. For more, see the One File Per Actor documentation. ChatGPT Part 3. NVIDIA DLSS, Deep Learning Super Sampling. Unreal Engine 5.0 introduces support for NVIDIA DLSS, a groundbreaking AI rendering technology that uses deep learning and AI to deliver high-quality, high-performance image upscaling. DLSS improves frame rates and provides sharper, more detailed images compared to traditional upscaling techniques. By leveraging the dedicated tensor cores on NVIDIA RTX GPUs, DLSS allows for real-time rendering with lower resolution input and then uses AI algorithms to upscale the image to the target resolution while maintaining visual fidelity. The integration of DLSS in Unreal Engine 5.0 brings the following benefits: increased performance. DLSS allows for higher frame rates by rendering the scene at a lower resolution and then upscaling it using AI, reducing the rendering workload on the GPU. Improved visual quality. DLSS uses advanced AI algorithms to upscale the image, resulting in sharper details and improved image quality compared to traditional upscaling methods. Flexibility. DLSS offers different quality modes, allowing developers to balance performance and visual fidelity based on their project's requirements. Hardware support. DLSS is supported on NVIDIA RTX GPUs, taking advantage of their dedicated tensor cores for accelerated AI processing. For more information on using DLSS in Unreal Engine 5.0, including implementation details and best practices, refer to the Unreal Engine documentation and NVIDIA's DLSS resources. Meta-Human Creator Integration. Unreal Engine 5 TES. The Meta-Human Creator, a cloud-based tool by Epic Games that enables the creation of realistic and highly detailed human characters. The Meta-Human Creator offers a vast library of customizable assets, including facial features, hairstyles, body types, and clothing options. With the Meta-Human Creator integration, you can easily import meta-human characters into Unreal Engine 5.0 and incorporate them into your projects. The integration streamlines the character creation process and allows for seamless integration of meta-human characters with Unreal Engine's advanced animation and rendering capabilities. By utilizing the Meta-Human Creator, developers can save significant time and resources in character creation, enabling them to focus more on other aspects of their projects. For more information on the Meta-Human Creator and its integration with Unreal Engine 5.0, refer to the official Epic Games documentation and resources. Please let me know if there's anything else I can help you with. User. It goes on. Automatic grid-based HLODs working with world partition. The automatic grid-based hierarchical level of detail (HLOD) system creates custom, data-driven HLOD layers to optimize large numbers of static mesh actors being displayed outside the loaded area. This feature provides a minimal set of HLODs using instanced static mesh components, ISM, or visible proxy meshes over unloaded world partition grid cells, reducing the number of draw calls and boosting performance. Image_23.jpg. These proxy meshes are generated using the original actor geometry and are simplified to reduce memory usage. For more, see the world partition, hierarchical level of detail documentation. Large World Coordinates. Large World Coordinates, LWC, introduces support for double precision data variant types in Unreal Engine 5, where extensive changes are being implemented across all